Malaysia announced a MH370 search extension for another year. But the question remains, where is MH370 to be found? And why has it not been found after 12 years? In this episode, I will compare the Boeing fuel analysis, the ATSB and Fugro search areas, the DSTG Bayesian model, Ocean Infinity's searches, the independent group proposal, the Blelly Marchand area, and the Whisper priority circle. The failure to find MH370 after 12 years does not invalidate the Southern Indian Ocean solution. It invalidates overconfidence in any single narrow endpoint model. The aircraft is not anywhere. The evidence still confines it to a finite family of seventh arc solutions. But the remaining uncertainty is large enough that even very capable sonar searches can miss if the probability map is wrong, or too narrow, or incompletely searched. Welcome to Independent Aircraft Investigations. My name is Richard Godfrey. This episode is titled, So Where is MH370? Malaysia has now extended the Ocean Infinity Agreement for another 12 months from the 1st of July this year to the 30th of June 2027, and that on the same broad no find, no fee basis. According to Malaysia, the remaining area is 7,428.54 square kilometers and part of the newer 15,000 square kilometer target zone. The search is expected to resume in the calmer southern hemisphere season, roughly between November this year and April next year. Armada 8605 covered on average 226.725 square kilometers per day per AUV in the January 2026 underwater search. At that January average production rate, 3 AUVs could theoretically cover the 7,428 square kilometers in around 11 survey days. And that is without allowance for weather or transit or terrain or infill lines or equipment issues in the launch and recovery cycles and data review. So where is MH370? MH370 is still most likely on or near the seventh arc in the southern Indian Ocean, but not in the areas already searched with high confidence sonar coverage. The aircraft is probably either just outside the previously searched high probability bands in a lower probability lobe created by an incorrect trajectory assumption, or in a searched area where the detection confidence was not actually 100%. And why has MH370 not been found? The core reason it has not been found after 12 years is not that the ocean swallowed a Boeing 777 invisibly. It is that the final location is derived from indirect constraints, not from continuous tracking. The Inmarsat data gives timing and Doppler constraints, not a precise track. The military radar ends near the Malacca Strait. After that, the aircraft's path, speed, altitude, turn timing, autopilot mode, fuel state, and end-of-flight dynamics have all to be inferred. The earlier official search was enormous. ATSB says the high-resolution sonar search covered more than 120,000 square kilometers of seafloor in one of the most remote parts of the Indian Ocean. But even that does not prove the aircraft is not nearby. It proves it was not found in the specific probability field and search width assumptions used at the time. There are 6 reasons why MH370 has not been found. First, the wrong latitude band may have been prioritized. The original search relied heavily on assumptions about a relatively stable southbound flight after the final major turn. If the aircraft made a later turn or several turns, speed changes, offsets, loiter, manual intervention, or non-simple autopilot path, the 7th arc crossing could move materially. Second, the 7th arc is a line of possible ranges, not a point. The aircraft could have crossed it over a very large north-south span. The BTO constrains distance to the satellite. The BFO constrains motion, but only imperfectly because it depends on aircraft dynamics, satellite motion, oscillator behavior, and assumptions about vertical speed. Ian Holland of the DSTG performed a BFO analysis, and this supports a rapid descent at the end. But it does not by itself give a precise impact point. Third, drift evidence helps, but does not pinpoint. The flaperon and other debris prove a southern Indian Ocean crash and broadly constrain the origin, but ocean drift is probabilistic. Cicero's drift and satellite imagery work strengthened the case for an area around 35.6 degrees south and 92.8 degrees east, but that still left a substantial search problem. UWA's oceanic drift modeling indicates that in terms of the timescales involved in the transport of the debris to Reunion Island, the most likely location for the origin would be between their location 11 at 33.2 degrees south and location 18 at 28.3 degrees south. Fourth, sonar coverage is not the same as certainty. Deep ocean search has nadir gaps, terrain shadowing, altitude control limitations, towfish and AUV line spacing issues, data quality variation, and contact classification uncertainty. Searched means search to a stated probability of detection, not mathematically eliminated. Fifth, the crash may not have produced an obvious compact debris field. A high-energy impact should leave a detectable field, but its appearance depends on impact attitude, breakup sequence, depth, seabed terrain, sediment, and how the engines, landing gear, wings, and fuselage separated. 6, the search has been intermittent and contract dependent. Ocean Infinity says that since 2018, it has spent 151 days at sea and mapped more than 140,000 square kilometers of seafloor in its MH370 efforts. The latest phase ended with the vessel leaving the search area on the 23rd of January 2026 without a finding. The 2025-2026 effort covered only part of the newly defined area before either weather, seasonality, or vessel commitments intervened. The remaining area is still around 7,428 square kilometers. MH370 is probably still in the southern Indian Ocean, close to the seventh arc, most likely outside the fully searched high probability areas or in an inadequately detected part of them. It has not been found because the search problem is under constraint. A small error in the assumed final trajectory moves the wreckage by tens or hundreds of kilometers, and the ocean search is vast and deep, remote, and probabilistic. On 28 April 2014, the Prime Minister of Australia announced that Australia, represented by the ATSB, would coordinate the underwater search for MH370. The ATSB subsequently formed two working groups. The aim was to define underwater search areas along the seventh arc in the Indian Ocean, where the SATCOM data indicated a power interruption close to the time of expected fuel exhaustion. An Inmarsat BFO model was finalized in April 2014. Inmarsat techniques applied to the model indicated best fit agreement for a 400-knot ground speed flight, crossing the second arc at a latitude of 2 degrees north and ending at 28.2 degrees south, 99.6 degrees east at 0019 UTC on the 8th of March 2014. The model provided reasonable matches for a range of ground speeds between 375 and 500 knots from the estimated second arc starting location, with end of flight between latitudes 25 degrees south and 37 degrees south on the seventh arc. Further flight path reconstruction techniques using this model were undertaken in May and June 2014, resulting in the orange priority area with latitudes between 27.4 degrees south and 32.1 degrees south. The ATSB-led underwater search was carried out principally through Fugro's search operations, including Fugro Equator, Fugro Supporter, Fugro Discovery, and the Fugro leased Havila Harmony. Go Phoenix and Donghai Ju 101 also contributed, but more in survey and support roles. The search area moved due to modeling refinements in 4 stages. The first area was 27.4 degrees south to 32.1 degrees south. The second area of 32.8 to 35.0 degrees south. The third area, 32.8 to 39.5 degrees south. And finally, the fourth area between 36.1 degrees south and to 39.5 degrees south. These changes were driven by BTO and BFO Inmarsat data modeling, constrained autopilot modeling, no pilot input after the Andaman Sea, an assumption of infinite fuel, and loss of control flight modeling, and the Cicero drift modeling. In November 2015, the Australian Defence Science and Technology Group, DSTG, published the Bayesian methods in the search for MH370. Professor Sir Adrian Smith, the Vice-Chancellor of the University of London, said, Dr. Gordon and his colleagues have employed these methods to provide a marvelous case study demonstrating the power of mathematical modeling and computation to attack one of the most intractable and uncertain puzzles of recent times. The highest probability area was centered on 38 degrees south, 88 degrees east, and the vast majority of the DSTG area was covered in the ATSB search by the end of 2016. Boeing conducted a detailed analysis of the fuel range and endurance. They estimated the MH370 remaining fuel at the first Inmarsat arc at 1828.05.9 UTC as it passed the northwest coast of Indonesia at 73,908 pounds. The maximum range from this point was estimated at 2,806 nautical miles and an endurance of 6.0 hours under the optimum conditions of the maximum range cruise thrust setting, a flight at flight level 400, a true airspeed of 469 knots at Mach setting of 0.818. In 2018, Ocean Infinity searched around 115,000 square kilometers using a ship they had leased, the Seabed Constructor, but unfortunately without success. Ocean Infinity extended the ATSB search area outwards from the 7th arc and went much further northeastwards to around 26 degrees south. In 2025 and 2026, Ocean Infinity again searched around 26,300 square kilometers using the Armada 7806 and Armada 8605, but again without success. Oliver Plunkett, the CEO of Ocean Infinity, said in a press release, "Since first embarking on this mission in 2018, the company has spent 151 days at sea and mapped more than 140,000 square kilometers of seafloor. It was important for us to take advantage of every piece of information and data available and go back, but despite all that effort, we haven't been able to find it. If nothing else, we can say with confidence that it isn't where we looked. That matters. It brings clarity, and it will help those continuing to study the evidence, refine their thinking, and shape future search strategies." I have digitized the ATSB 2014 to 2016, as well as the Ocean Infinity 2018, 2025, 2026 data, and it totals a search area of 262,288 square kilometers. The map comprises 388 cells, each 26 kilometers by 26 kilometers, representing the seafloor sonar coverage in the MH370 search areas. The ATSB estimated the sonar coverage of its search area at 97.1849% reliability. That is their published figure, not a claim of mathematical certainty. It means the ATSB regarded the search areas as very highly covered, but not absolutely eliminated. Ocean Infinity states more definitively that MH370 is not where it searched. The analysis published 30th of August 2023 by Ullich and Yunello took 3 years to complete. The study shows a high priority search area denoted Zone 1A and centered on 34.23 degrees south, 93.79 degrees east. The Zone 1 is between 32.9 degrees south and 36.4 degrees south, and either side of the 7th arc at the previous ATSB search width, which was from 35 nautical miles in front of the 7th arc to 20 nautical miles behind the 7th arc. Zone 1 is 566.40 kilometers by 101.86 kilometers, an area of 57,693.50 square kilometers. The IG map depicts 3 zones between 31.5 degrees south and 36.7 degrees south. Zone 2 should be searched if Zone 1 is unsuccessful, and Zone 3 if Zone 2 is unsuccessful. The IG Zone 1 search area has been covered completely by ATSB and revisited in part by Ocean Infinity. The analysis by Captain Patrick Blelly and Jean-Luc Marchand, dated 22 March 2023, took 4 years to complete and was published as a book as well as a paper. The central priority search area is 350 square nautical miles, or 1,200.47 square kilometers, and has been searched completely by Ocean Infinity. The total Blelly-Marchand search area is 1,200 nautical miles squared, or 4,115.88 square kilometers, and has been almost completely searched by Ocean Infinity, with the exception of a small part of the southeastern corner. I performed an analysis together with my co-authors, Dr. Hannes Kurtzi and Professor Simon Maskell. It took 5 years of work and resulted in the publication of 6 papers since 2021. The essential premise is that aircraft can be detected and tracked using anomalies in the historic WSPRnet propagation data. The WSPR search area is a circle of radius 30 kilometers, centered on 29.128 degrees south, 99.934 degrees east, and totals 2,827.43 square kilometers. No AUV launch and recovery mission has covered any part of the WSPR priority circle. So what is our conclusion? A total of 262,288 square kilometers has now been searched. For the ATSB component, the final report estimated coverage at 97.1849%. Ocean Infinity has stated more definitively that MH370 is not where it searched. Taken together, the major previously prioritized areas have been tested to high confidence. But no AUV launch and recovery mission has covered any part of the WSPR priority circle. The proposal to search the Whisper area was first made to the Malaysian authorities in May 2024 by Professor Simon Maskell during the presentation by Ocean Infinity. My recommendation is that Ocean Infinity and the Malaysian authorities include the Whisper area of 2,827 square kilometers within the remaining 7,428 square kilometer search commitment. Thank you for watching, and if you enjoyed this analysis, please subscribe for future investigations.